Differential equations 4.6 day 2. We're just going to finish up evaluating this W sub 3, this 3 by 3 determinant. And, we can definitely do this with calculator or without. I encourage you to do this without, just in that it's going to honestly be way quicker. So W sub 3, looking at the top, this is positive. You'd have negative sign times secant. And then take a look at the bottom. Every diagonal here has a 0 in it. It multiplies to 0. So that's your W sub 3. Now, by the way, secant, of course, is 1 over cosine. So honestly, this is just negative tangent. So we've been doing some work right here off to the side, and that third function u sub 3, when you take the derivative of it, it would be w sub 3 over w. And w, the original Wronskian, was a 1. And here we have negative tangent of x. So we're just going to go ahead and take our integral here, take our antiderivative, and you'll see u sub 3. Well, here's the thing. It's been a little while since maybe you've done an integral of tangent. Probably you think of the natural log of absolute value of secant, but if you have a negative out in front, that can be raised up, and it's actually going to get you the natural log of cosine of x. You definitely could also have done this many different ways. You could have turned that into sine over cosine and have done a u substitution, let u equal cosine. It's all good, regardless of which way you're doing it. But you've got your u sub 3, u sub 2, and your u sub 1. Well, let's revisit. I'm going to come back up here and just get this written out again. Y sub p, we found that u sub 1, well, that was this thing right here, the natural log of secant plus tangent. And of course, we could have that as times a 1. What am I really referencing right now? Well, this thing right here. That was our y sub p, our particular solution. We could say u sub 2. Well, our u sub 2 was actually nice. It was just negative x, wasn't it? We could say, well, that's negative x times the cosine of x. And then our u sub 3 multiplied to sine, well, we just found that that's the natural log of the absolute value of cosine. And that's going to get multiplied to the sine of x. And remember, we also found what this y sub c was. I could even recopy that. That was c sub 1 plus c sub 2 cosine of x plus c sub 3 sine of x. Well, the thing is, our final answer is really y sub c. And then we're going to add to that our particular solution. That's what we have right up here. We'll have natural log of secant of x plus tangent of x. We don't have to say times 1. We could say minus an x cosine of x. And then we could say plus this natural log of the cosine of x times sine. And we could put the sine out in front, of course. But rather lengthy and long answer, but that's it. That's our example. This third degree, kind of a situation, a degree 3 derivative differential equation can be a long problem for sure, but this is honestly how you do it. Let's take a look at example 2 real quickly. And for example 2, I do want to just mention that this one actually isn't as long in regard to, using this new method involving the Wronskian. If you're looking at the right-hand side, you might notice that this looks reminiscent on what we've been doing recently. First of all, let's just address solving this differential equation if it were equal to 0. And that's going to involve, assuming that we have y equals e to the mx. And this thing right here is going to factor. See, it looks like a 2m and an m. I'm seeing a -1 and a +1 because we're going to have to be able to add to a 1m. We see that in the middle, and yet multiply to a -1. We'll have 2m minus 1 equals 0. M plus 1 would equal 0, so we'd get m equals -1. Here, if we add a 1 and divide by 2, we'd get m equals 1/2. So this is going to lead us to our homogeneous solution. We'll say, well, c sub 1, and we'll have e to this first m, that's 1/2 x, plus c sub 2, e to the -1x. And hey, look at that. Now the right-hand side, very much a review problem right now, and nice to see it. In fact, our particular solution that you very well might want to try, via our table that we've been talking about, sure looks like we've got a linear form. Let's just write that as a to the x plus b, and take a derivative. We just have an a second derivative, we just have a 0. And my word, if we were to substitute that all in, let me just recopy what we have here. If we were to just substitute that all in, we'll have 2 times 0 plus, what's y prime? Well, we'd plug in an a, and we'd say minus. Well, our y right here would be ax plus b, and then our right-hand side is just x plus 1. Well, you distribute this negative, and you'll have a minus ax minus b. And by the way, we're going to do some coefficient analysis right now. We'd have negative ax, then we'd say plus, here's an a minus b. And again, nice review problem right now. All you got to do is just pay attention to what's in front of the x right here. And you can quickly say, well, I'm going to have negative a is equal to a 1. And then we're going to look at our constant, that's a minus b. Well, that should equal a 1 also. But if a is equal to -1, well, then we can substitute that in here. And my goodness, if we were to add a 1 to both sides and then divide by a negative, b would equal -2. So again, we had this idea that our y sub p should be ax plus b. Well, we'd have -1x, and our b is going to be a -2, so we'd have y sub p is -x minus 2. So that's all well and good. It's just that right now we're going to say, hey, our general solution then should be our homogeneous solution that we found at the start. And then we'll put in our particular. And so very often we would just stop right here and we'd say, okay, wonderful, we're done. But notice what's going on. Right now we're going to say, well, we've got an initial value problem. And we're going to make use of that right now. Y of 0 is equal to 1. So we've got y of 0 equals 1. That means x equals 0, y equals 1. Let's go ahead and see what we get. Plugging in an x equals 0, well, that's going to be e to the 0, which is going to be a 1, isn't it? And you can see very quickly you'd get c sub 1 plus c sub 2, because e to the 0 is 1. How about we add a 2 over here, and hey, just like that, we've got this nicely set up. And forgive me, I just made a little mistake. Y is equal to a 1, isn't it? I just looked at that answer right there. When you add a 2 over, so sorry about that. There we have it. You know, C sub 1 plus C sub 2 would equal 3. And you'd say, okay, well, we're getting somewhere. But here's the thing. We also have to do some more work. We have this for our solution, but we also have an initial value property involving the derivative. I'm going to take the derivative, chain rule, bring down a 1/2 out in front here. Derivative of e to a power is e to that power, but the derivative on the inside, out comes a 1/2. Over here, derivative of e to the negative x, a negative comes out. Look at that. Derivative of negative x is just -1, and the derivative of -2 just goes away to 0. So we're well on our way. Now we're going to have y prime of 0 equals 0. So we've got y prime of 0 equals 0. That means when x equals 0, y prime equals 0. So plug that in. We're going to say, look, your left-hand side now is a 0. Take a look at your right-hand side. E to this 0, hey, that's just going to become a 1, isn't it? And just like that, things are going to clean up in a hurry. Tell you what, I'm going to add a 1 to this side real fast. And I personally don't like to see these fractions, so I'm going to multiply everything by a 2. Okay? And then over here, we're going to have our 3 equals c sub 1 plus c sub 2. And tell you what, I'm going to multiply this 3 equals c sub 1 plus c sub 2. I'm going to multiply that by a -1. You might say, why are you doing that? Well, going back to Algebra 1 days, we're going to do elimination. We're going to cancel this out. We'll have -1, 2 plus -3 is going to equal -3 c sub 2. And that means c sub 2, when I divide by a -3, is going to be 1/3. But tell you what, I'm going to use this 3 equals c sub 1 plus c sub 2 and just go ahead and solve for c sub 1 now. 3 is 9/3, isn't it? So I have 9/3 is equal to c sub 1 plus 1/3. When I subtract 1/3, I'll get 8/3. So now I know what my c sub 1 and my c sub 2 are. And let's just revisit what that answer was right here in green. We had y was equal to c sub 1 e to the 1/2 x plus c sub 2 e to the -x minus 1x minus 2. Now I know what my c sub 1 is. It's 8/3. Now I know what my c sub 2 is. It's 1/3. And I have minus x minus 2. And we are done. That wraps up section 4.6, day 2.